In this session, we're going to set up Hunk on Amazon Elastic MapReduce. The steps we're going to go to are to first add data to S3 buckets. Second, we will create an EMR Hadoop cluster. We will then, using the CloudFormation, create a Hunk Hadoop client node that will automatically discover our EMR cluster. Fourth, we will create a virtual index that will point to our S3 buckets. Although Hunk automatically finds the Hadoop EMR cluster, we will still need to tell it exactly which bucket contains the data. The final step is we will create analytics and visualization using the Hunk UI. To start the setup, we are going to go to the AWS Elastic MapReduce Hunk page, which will take us to the documentation to set up this solution. All the steps for these setups can be found under the Splunk documentation under the Hunk user manual, and from there you can go to the Hunk on Amazon Web Services hourly pricing. In here you can see the step to set up your AWS account, to launch an EMR cluster, the two options that we can see on step 3 is about provisioning a Hunk instance. We have an option for doing it using a CloudFormation template or manually through the EC2 console by providing an AMI ID and your own security. And finally, the last step, step 4, is about logging into Hunk and the right steps to do such a thing. Once on the AWS page, we're going to go to the AWS Management Console. And the very first thing is we're going to look at the S3 buckets for the raw data. For this particular setup, I have a bucket under S3 called raw none, and underneath that, I have a directory called data, and in there we have the access_combine.log that Hunk is going to use. The next step is to provision several Hadoop nodes. To do that, we're going to go to the EMR section and we're going to create a cluster. We're going to give it a name, Hunk EMR Cluster. And also we're going to provide a log folder on S3. And as we've seen before, we have a bucket called raw none, and then underneath that, we're going to log the data into the log directory. Then we're going to provide a key value. This is purely optional. And the next thing we have to do is to select the AMI version. Hunk supports any version above a 3.0.3. And so just selecting the latest will be fine. We then going to select an additional application. We're going to select that link and we're going to pick Hunk as the service that we're going to configure and add. Click Enable. Now we see Hunk as additional application. We are not going to use Hue, Pig, or Hive, so I'm going to remove those. Next, we are going to select how many tasks we would like to be used as part of this cluster. I am going to choose 5 core nodes, which is the ability to store data in HDFS and process the data in HDFS, and 5 task node, which is the ability to store the data in S3 and process the data in HDFS. I'm also going to change the default hardware for these nodes for C3 extra large for the core, as well as the task from the default medium size. The next part that we have to configure is the security and access for the cluster. So in this case, we're going to provide the EC2 key pair that was given to us when we first initiated the authentication for the AWS. And the last part that we have to do before we generate the cluster is to pick up the roles for this particular setup. I'm just going to stay with the default roles. So now we can just create the cluster. So while Amazon is provisioning these task nodes for us, we are going to create the Hunk client node to connect to the cluster. To create a Hunk client, we have two options. We can either go and create a new instance using EC2, launch an instance, and then search for an AMI based on the recommendation in the Hunk documentation. You can find this list. So for example, for Oregon, this is the right AMI ID. The second option that we have is we can go in and click on the CloudFormation and use from an existing template that was created for us for this integration. Looking back at the documentation, we can also find a shortcut to start a CloudFormation template. So in this case, I'm going to use the Oregon CloudFormation for Hunk. As we can tell, the template that was populated from the documentation shows the Hunk EMR hourly as the name, as well as the description, and all the rules were provided as part of the template.txt. We're going to click on next, which will take us to what kind of hardware we want. In this case, I'm going to increase the hardware to something a little bit more significant, like the C3 2X large, which will give us about 8 virtual CPUs. The key name is the SSH access that was given to us when we first created this account. So this is the name. The storage is simply for the Hunk node to be able to store applications as well as users. It's not for raw data. Click on next. Now all we need to do is just to create the Hunk node. After a few seconds, we can see the progress of AWS generating our Hunk client. Once the template has created Hunk, we can then click on the Output subtab and see the URL for Hunk, the username and password to log in into Hunk, as well as the public IP. So with that, I'm just going to copy the password and go to Hunk. After logging in, you will be redirected to the Hunk tour. This is something that we very much encourage for people to go and take the tour end to end to learn about the capabilities of Hunk as far as visualizing and analyzing data from S3. In addition to taking the tour, we can also go to a Splunk EMR connector. The Splunk EMR connector is an app that can show us the status of the cluster, whether or not it's active or how many inactive clusters, as well as the details of our EMR cluster itself. We can then see on the right side the number of master nodes and the node that we created earlier on AWS. We can also see underneath settings, virtual indexes, that this integration already generated a Hunk EMR cluster provider for us, including all the configurations that are needed to connect to our cluster that we generated a minute ago. The next part that we need to do is we go to the virtual indexes, select the virtual indexes subtab, and create a new virtual index. We're going to give it a name. We are going to give it the right provider, the one we just generated, as well as the location of the data in S3. We can further define whitelist files that we want to specify or customize timestamp format. Once we save that, we can then go in and directly from the Hunk UI search through the provider to our S3 buckets. We can now go in and generate MapReduce jobs to enable us to analyze and visualize data from AWS. For example, clicking on the top value will allow us to generate a map job which will run in EMR, pulling the data from S3 and generating MapReduce jobs on our behalf in Amazon. Once the MR job has been completed, and we can see it by the green check mark, we can go in and, as we have seen in other Hunk demos, we can change the visualization, we can save this data as a report, a dashboard, alert. We can go in, build nice dashboards, as I've just shown you, with mapping and any of the other elements that Hunk is known for. In addition, once we go into the app called EMR Connector, we can also directly from here go back to the EMR console and look at our running instances. For example, in this case, we have several running instances, and at any given point, we can see which one is the Hunk client and which ones are the Hadoop task nodes, and we can shut them down and get charged only for the amount of time we spend processing this specific dataset. To learn more, feel free to go to Splunk.com underneath products and click on the link for the Hunk product. Thank you.